Good morning. So today we are going to go through the graphs that we did not do. So this last one we did not do in class, so I want us to look at it. So it is y equals -3 sine 2 pi x plus a 2. And I put this in parentheses right here because this is inside your sine function. The plus 2 is going to be on the outside of your sine function. So here the amplitude is going to be the absolute value of -3, which is going to be a 3. Your period is going to be 2 pi divided by the absolute value of your b right here, which is 2 pi. So your period is just going to be a 1. So that means that one full cycle of your sine graph is going to go from 0 to 1. So we would need to divide. So to find your x values here, to find one period of your sine curve, you would need to go from 0 to 1. So you need to find some values inside, in between 0 and 1 to graph. So what you will do is you will divide 1 by 4, so you'll get 1/4. 1/4 plus 1/4 gives you a 1/2. 1/2 plus 1/4 is a 3/4, and then 3/4 plus a 4th gives you back to a 1. Okay, so that is one period of your graph. There is no phase shift because there is nothing added or subtracted inside the sine function. There is a vertical shift, so it is going to be that value it's going to move up to. Okay, so what is happening is that I have shifted this graph from 0 all the way up to 2 right here. So sine of 0, 2 pi times 0 is a 0. So sine of 0 is 0. And then 0 times -3 is a 0. And then 0 plus 2 gives you 2. So I have shifted this graph all the way up to 2. Okay, so basically this shifts the sine graph. It's called the midline. The midline is what is where your graph starts. Okay, remember your amplitude is half the distance from the midline, basically. So what you're looking for then is that if your midline moves up to here, so my amplitude is 3, so that means that I will be going down 30. And I will be going up 30 from that midline. Okay, so that's how you can use that midline there. So when you're moving up and down, your midline is going to change. Okay, all right, so if you were to plug a 1/4 in here, then it would be sine of pi over 2. Sine of pi over 2 is a 1, and then 1 times -3 is a -3. -3 plus 2 is a -1. So we will be down here at -1. Or basically, you're just going to go down 1, 2, 3. Okay, 1/2 is going to be the same thing. So sine of pi is 0. And 0 plus 2 gives you a 2 here, because sine of 0, right? All right, sine of 2 pi times of 3/4 there. So that would be what? Sine of 3 pi over 2. So if you were to plug in a 3 pi over 4 right there, it would be sine of 3 pi over 2. Sine of 3 pi over 2 is a -1. A -1 times a -3 is a +3. 3 plus 2 gives you 5. So that's how you move up to 5. And then sine of, when you put a 1 in there, 1, so you're basically saying sine of 2 pi. 2 pi is a 0, then 0 plus 2 here gives you back to 2. Okay? All right. So, this one down here, it says the picture below shows the depth of water at a boat dock varies with the tides. The depth is 5 feet at low tide and 13 feet at high tide. Okay, so we have depth at 5 feet at low and 13 at high tide. Low tide occurs at 4 a.m. and high tide occurs at 10. Okay, so in between here, right here, is going to be a 7. Okay, so we know that this is 7 and this is about 19 here. So it's in between 16 and 22. All right, so we are looking at the sine curve. So this is going to be y equals a times sine of b. I'm going to do this, x plus a c plus a d. So I'm going to change it a little bit like this. Okay. So my A is going to be my amplitude, right? So from here, from 9, this is my midline, right? So D, how about that? So I have moved up So D is going to be 9 units. I have moved my graph 9 units up. A is going to be the distance from my maximum and my minimum here, right? So my maximum, my minimum, we've got 9 minus 13 is 4. 9 minus 5 is 4. So your amplitude is going to be a 4. And we are, if you were looking right here at this graph, we're the standard sine curve, so there is no, shouldn't be a negative, so there shouldn't be a flip of it. So then we're going to have sine of some b, and then plus some c. Okay? Alright, so the difference here, one period of my graph is going to be from 19 to 7. So 19 minus 7 is a what, 12? Alright, so one period is going to be equal to 12, right? So this is a sine graph, so how could I find my b? So I would say 12 is equal to 2 pi over b. So b is going to be 2 pi over 12, and y'all can't see that, I'm sorry. So b is going to be equal to pi over 6. Okay. Usually your sine curve starts at 0, right? But I have shifted this over to the x value of a 7, and I have shifted it to the which direction? Okay, so I've shifted it to the right. So inside of here needs to be a minus sign. So I need to change that plus sign to a minus sign. So this is going to be minus a 7. So this is what your new curve looks like. So you could say 4 sine. And now if you multiply this together, so this will be pi over 6x. And this will be minus 7 pi over 6. And then plus a 9 will be on the outside. Good. All right, so today we're going to look at graphs of secants and cosecants and tangents. Okay. All right, so what do you notice about cosecant is the reciprocal of sine, right? So here, this dotted line right here is your sine graph. So if it's the reciprocal, what's going to happen at pi, 0, 2 pi, 3 pi, and a negative 2 pi? It's going to become undefined, right? So at these values, you are going to have a asymptote. Okay. So basically you need to draw. So cosecant, you will need to draw your sine curve. And secant, you'll need to draw your cosine curve to kind of help you do these. So then from 3 pi over 2, or this negative 3 pi over 2, we will be opening upwards. From this peak, we will be opening downwards. And we're never going to touch those asymptotes. We're going to open upwards. We're going to open down. We're going to open up. Okay. So the domain of your cosecants are all real numbers. Except for multiples of pi. Your range is going to go from 1 to infinity, and then from negative infinity up to negative 1. So your range of values are going to go from negative infinity to negative 1. And then again, so you're skipping these values here, and then from 1 to positive infinity. The period still is going to be 2 pi. Symmetry here, so it's going to have origin symmetry. And it is a odd function. So secant, same thing's going to happen. So secant is the reciprocal of cosine. So at negative pi over 2 and negative 3 pi over 2 at positive pi over 2, 3 pi over 2, 5 pi over 2. You are going to have a asymptote. And the same thing's going to happen. So at negative 2 pi, you'll be opening up. At negative pi, you're going to be opening down. At 0, you're going to be opening up. At pi, you will be opening down. At 2 pi, you will be opening up. So at each one of the peaks and the valleys, you will be opening. At the valley, you'll be opening down, and at the peaks, you'll be opening up. So domain still is all real numbers, except for what? Multiples of pi over 2. Range of values, same thing, is going to go from negative infinity to negative 1, and then again from 1 to infinity. Period is 2 pi. Symmetry, cosine is an even function, right? So symmetry here is going to be y-axis. So if you were to draw a line through the y-axis there, it would have symmetry, and it does. Okay. So same thing happens with your graphs, how they shift, vertical and horizontal translations, and how your period changes and all that good stuff. Okay, so let's look at this question here. It says y equals secant of 2x. So that is y equals cosine of 2x. So if I were to graph y equals cosine of 2x, then I would be able to draw secant of 2x. It would help me a little bit. So let's start with drawing this one. So what is the amplitude? Is a 1. The period is going to be 2 pi divided by 2. So the period is going to be pi. There is a shift, and there is no shift in the graph, vertical shift. So I'm going to have 0 to pi. Okay, divided by 4. So this is going to be pi over 4. This will be pi over 2. This will be 3 pi over 4. It says to graph 2 periods of it. So if I just did this one more time, so then it would be pi plus pi over 4. So that's going to be 5 pi over 4. Then it's going to be, what, 3 pi over 2? Then it'll be 7 pi over 4. And then it'll be a 2 pi. Did I get all of them? Pi. Okay, so if you were to plug a 0 in there, 0, you would be at a 1. At pi over 4, you would be at 0. At pi over 2, you will be at a negative 1. At 3 pi over 4, to plug it in here, so it would be cosine of 3 pi over 2, so you'll be back at 0. And then at pi, you'll be back at 1. And then I'm just going to follow suit. So this is just going to happen all the way through. Okay, so I'm going to just do just a little dotted line here so that you can kind of see what I'm doing. Okay, So that's your cosine. So now, at each one of these, so at pi over 4, you are going to have an asymptote. At 3 pi over 4, you are going to have an asymptote. At 5 pi over 4, I'm going to have an asymptote. 7 pi over 4, I'm going to have an asymptote. So here, I'm going to be opening up. At here, I will be opening down. I will be opening up. I will be opening down and up. Okay. All right. So I want y'all to do this one for me, the cosecant one. So you should be able to do that one. So that one just basically, first thing that you would need to do is graph your sine curve. So this one does have a phase shift. It is going to shift to the left pi. All right. So now let's look at cotangent and tangent here. So cotangent and tangent. Tangent is the ratio of sine over cosine. So sine over cosine, what is going to happen? This is your sine graph up here, and this one was your, this is your sine graph, and this is your cosine graph. So if you were to, at 0, okay, so at 0, here's your sine over cosine. So 0 over 1 is going to be 0, right? Pi over 2, what happens at pi over 2? So sine is going to be 1, but cosine is a 0. So 1 over 0 is undefined. So I am going to have an asymptote there at pi over 2. Okay. At pi, you will have a 0 over a negative 1. So that is going to be a 0. So at pi, you will be back at 0. 3 pi over 2, what's going to happen at 3 pi over 2? It's undefined. 2 pi, we're going to be back at 0. 5 pi over 2. So if I keep doing this, so at pi's, we are going to have x-intercepts at all the pi's. All right, so in between here, so pi over 2, so if I was to maybe do pi over 4 would be a 1. A negative pi over 4 would be a negative 1. So what is my graph going to look like here? So it's going to be a snake all the way up. Cotangent's going to be the opposite direction, right? All right, so the domain here is all real numbers, except for what? Except for pi's over 2's, right? Let's call it n pi's over 2. Range here, all real numbers, right? So it's going from negative infinity to infinity. The period here, what is happening for me to start one cycle of my graph? So just, let's look here. So from 0, and then we're coming, and then we're going again, right? So we're starting over. So from 0 to pi is one period. So your period is going to be pi. So instead of 2 pi, your period for tangent and cotangent is going to be pi. So remember, you do have this b inside here. So your period would get divided by, when you're finding it for other graphs, it would get divided by that b. Okay. All right. The vertical asymptotes are going to occur at every pi over 2. X-intercepts are going to all be at intervals of pi. Symmetry here, it's got origin symmetry. And it is an odd function. Basically, you can repeat that over here, except for it just looks a little bit different. So the same thing is going to happen is you're just going to be shifting over, but at 0 here you are going to be undefined, right? Because remember, cotangent is cosine over sine. Right? So you're going to have an asymptote at 0. Oops, I'm sorry. So the asymptotes are changing a little bit. So the domain here is going to be all real numbers except for intervals of pi. Range is going to be negative infinity to infinity. So what's going to happen here, so we're going to have pi over 2, so at a pi over 4, we are going to be where? So at pi over 4, we are going to be at a 1, and then at 3 pi over 4, here we're going to be at a negative 1. So it's going to be decreasing like this. It's going to snake down. So it's going to look like the cubic graph almost, except for it's got lots of them, lots of little snakes going on. Okay, so the period still is going to be pi. When we're doing other graphs, it is going to be pi divided by your b. Vertical asymptotes are going to occur at intervals of pi, multiples of pi. The x-intercepts are going to occur at pi over 2. It is origin symmetry, and it is odd. Okay. Alright, so let's look here. So determine the period and transformations here. So your period here is going to be, nothing is there, so it is just going to be a pi. But this negative pi over 2 means that I'm going to shift it to the right pi over 2. Okay, so I'm going to take my normal tangent curve, but I am going to shift it over pi over 2. So that means, okay, that so I'm shifting this to right here, right? So that means that my asymptotes are going to occur at pi's. Okay. So while we're down here, so here I've got a pi. We'll call this 2 pi, and then we'll call this 3 pi. So they are going to be our asymptotes. So our other asymptote is going to occur at 0. So at pi over 2, at 3 pi over 2, at 5 pi over 2, and so forth. We will have our graph here. Okay, good up, not too bad. Cotangent, so this one is cotangent of 3x, so the period here is going to be pi divided by 3. There is no phase shift, there's no vertical translation, so the period then, instead of going through a pi cycle, it's going to go through a pi over 3. Okay, so that would be here, this would be pi over 6. This would be pi over 2. This would be a 5 pi over 6. Cotangent is going to decrease. Each time. Okay. Alright, so I want you to try to do C for me, and then start working on your homework. Okay. Your quiz is just going to be on just your sine and cosine graphs. So this is not going to be on your quiz, but it will be on your quiz next week. If you have any questions, let me know. Y'all have a good day.